All right, hopefully you found the right video. Algebra 2, lesson 5.1, multiplying polynomials. Hey, this is old hat stuff. This should be a really easy lesson. I'm going to try to go quickly for you. What's the big deal with multiplying polynomials? Actually, there is none. You're simply going to distribute, right? So the key is distribute. We know how to do that. We know how to do that well. You've got an example here, the distributive property of multiplication over addition. Hey, what do you get? A times B plus A times C, right? We're simply distributing what's out in front of a parentheses to everything inside the parentheses. Distributive property. Piece of cake, right? You guys know how to do this. We've been actually doing it already. So a couple quick examples and we're going to move on. First one, a monomial times a polynomial. So what do you have out in front of this binomial right here? This polynomial is one term, a monomial. All right, no big deal. We're just going to distribute. Negative 4n times a 7n, negative 28n squared. Right? Be careful with your n. That is an n squared, not an n. And a negative 4n times a negative 2 is a positive 8n. That's it. Right? That's it. You distributed. Piece of cake. No sweat. All right, go ahead and do B. I'm going to pause, and when you're done, go ahead and unpause the video. All right, so hopefully you got it, what, a negative 10 a cubed b cubed plus 6 a squared b to the fourth minus 2 a b to the fifth. We're just distributing, right? Piece of cake. It's easy stuff. No problem. All right, be careful with a problem like this. And what happened to my... All right, I'm a little ahead of myself. All right, let's take a look at B. Binomial times a binomial. Binomial times a binomial. So a polynomial with two terms times a polynomial with two terms. Now, again, many would at this point teach you the acronym of FOIL, which is basically a way of remembering how to multiply a binomial times a binomial. What does FOIL stand for? You multiply the first terms, that's an F, and then you multiply the outer terms, which is an O, and then you multiply the inner terms, which is an I, and lastly, you multiply the last terms, which is an L, and you multiply those two binomials, first, outer, inner, last. And you know what? If that's what helps you to remember how to multiply binomials, that's fine. But honestly, if you'll just learn how to distribute, then you'll know how to multiply any polynomial times any polynomial. And we already know how to do this. So we're going to distribute the x times the 3x and get a 3x squared, the x times the positive 5 and get a positive 5x. We're just distributing. And then we're going to distribute the negative 4, right? A negative 4 times a 3x is a negative 12x. Notice how I like to line up my terms underneath, the like terms, because I'm going to add those up. Negative 4 times a 5 is a negative 20. We'll just finish this up by adding up our like terms. And so we get 3x squared minus 7x minus 20, right? 3x squared minus 7x minus 20. All right, why don't you go ahead and do B. I'm going to pause. You should pause as well and then restart it as soon as you have your answer. Okay, so hopefully you distributed. So you ended up with what? 15y squared minus 21y and then plus 20y minus 28. And hopefully you end up with a grand total of 15y squared minus y minus 28. Not tough at all. Pretty simplistic. All right, well, let's look at C. Hey, be careful with C because students make a common mistake on C. They think that this equals this, and it does not. Okay, but this is what students think. Students think this is a 2n squared minus a 9 squared, and that is not true. Don't make that mistake, because if you do, you're guaranteed to get the problem wrong. Instead, what you have to say here is this is a 2n minus 9 times a 2n minus 9. Right? What does squared mean? Multiply the base times itself. Okay, so now if you go ahead and finish that problem, you're going to get the correct answer. Otherwise, you would be wrong. So let's just finish this off real quickly. Right? This is a 4n squared negative 18n Now distribute the negative 9, again another negative 18n and a positive 81. And you see we end up with 4n squared minus 36n plus 81 as you make that distribution. Okay? All right, C, or number 3 here. How about a polynomial times a polynomial? Now look, it doesn't matter whether it's a binomial times a polynomial trinomial, or a trinomial times a trinomial, or a 4-termed polynomial times a 5-termed polynomial. It just makes for a big problem, but all you have to do is distribute. So look, all you do is distribute. X squared times 2x squared. We all know that's a 2x to the 4th. And x squared times a positive 5x. We all know that that's a positive 5x cubed. And x squared times a negative 7, negative 7x squared. Hey, we're just distributing. That's all you're doing. Now let's distribute the negative 3. Negative 3 times a 2x squared to negative 6x squared. And again, notice I'm going to line up my like terms. Negative 3x times a 5x, negative 15x, and a negative 3 times this negative 7 is a positive 21. All right, add it all up. 2x to the 4th plus 5x cubed minus 13x squared minus 15x plus 21. Okay? So just multiplying, in this case, a binomial times a trinomial. Second example, again, is a binomial times a trinomial. Look, it wouldn't matter if it's a trinomial times a trinomial. You distribute. However many terms are in the first parentheses times however many terms are in the second parentheses, just distribute. All right, again, pause the video. I think you should work the problem yourself, and then unpause it, and I'll go through my explanation. All right, so you're distributing, what do you got, an 8y to the 4th. You've got a 14y cubed, and you should have had a negative 6y squared. Use my green here. Let me go over the top. So what is this? A 20y squared. It's right, positive. And this is a 35y, because we like it like that. And a negative 15. And hopefully you ended up with 8y to the 4th plus 14y cubed plus 14y squared plus 35y minus 15. All right, a little long, but not hard. You're just distributing. A little long, but not hard. All right, this next section are a couple patterns that you're supposed to learn. And to be honest with you, the patterns can give you a little bit of a shortcut in solving some of these. And you should learn the patterns, but you can also simply distribute. All right, well, let's go through the patterns, and then I'll show you how we'll use them. The first is the square of a sum. So your base is two things added. That's the sum part, and then you have to square it. So that's why we call it square of a sum. Not a big deal. All right, notice that there's a positive sign between them. So in your pattern, it's going to equal the first term squared, that's the a squared, plus sign. Grab your blue and a 2, and you have to multiply 2 times the a times the b, and then plus the b squared. That's just the pattern, okay? Not a big deal, pretty simplistic, but that's a pattern whenever you have that square of a sum. What about the square of a difference? All right, this time, again, the two terms of the base are being subtracted. So that's why we say square of a difference, right? Because they're being squared, but the base, the terms are being subtracted. All right, take the first term and square it, minus sign. Still need your 2. Then take the first term times the second term, and then finally plus the back term squared. So watch again. First term squared, same sign as between them, minus sign, times 2, first term times last term, plus the last term squared. That's the pattern. Again, a little tricky, but not that big of a deal. Third one, products of conjugates. This is also the difference of two squares. The difference of two squares. This comes up all the time when we get to factoring, And really, we do it in reverse. All right? You've heard me say difference of two squares. So in this direction, you have the products of conjugates producing the difference of two squares. When we factor, we go in reverse. We take this and factor it back into that. Okay, not a big deal. Um, so what it's going to be the first term squared minus sign and the second term squared. Whatever is the first term of each is going to be squared minus whatever is the back term of each. And again, just let me be clear here. Anytime you see A and A, that means those terms match. B and B, those terms match. Okay, not a big deal. Just some patterns to learn. Let's go ahead and use them. Okay, so number one fits the pattern of B, right? The square of a difference. So let me use a little color here. So the 5x is the A. The negative 3 is the B. Okay, so we're supposed to take the A and square it, right? Then we're supposed to do a minus, and then a 2, and then we're supposed to multiply that times A, which is 5x, times B, which is 3, and then we're supposed to have a plus sign, and then we're supposed to take that last term, that B, that 3, and square it. So where do we end up? 5x squared is 25x squared. Negative 2 times 5, negative 10 times 3, negative 30x, and then plus 9. So 25x squared minus 30x plus 9. Now, in all honesty, you could take this binomial, you could write it out, and just multiply it out. So again, you might say, well, which one's easier? Well, look, 5 times 5x times 5x is 25x squared. 5x times, and that's a 3 there. 5x times a negative 3 is a negative 15x. A negative 3 times a 5x is a negative 15x, and a negative 3 times a negative 3 is a positive 9. Final answer, 25x squared minus 30x plus 9. So you get there either way. So you're going to get there either way. So again, you could just distribute if you don't remember the pattern. All right, here's a scenario. This is the product of the conjugates. So this is a bit of a shortcut. It does save you time. Again, when you understand a difference of two squares. So in this scenario here, the 2n is the A, right? And the 3y is the B. So the pattern is the A is squared minus the B is squared. So this is a little quicker, and we end up with a 4n squared minus 9y squared. Difference two squares. Again, you can just multiply them out by distributing. You're going to get to the same place, 4n squared minus 9y squared. So if you don't remember the pattern, just distribute and multiply them out. All right, one last problem here. So we got a compound problem. And basically you just have four things multiplied together. There's thing number one, thing number two, and remember this is an x plus 2 times an x plus 2, so thing number 3 and thing number 4. I feel like I'm in Cat in the Hat. All right, in French, chapeau. In Spanish, el gato en el sombrero. All right, I got to get off Cat in the Hat. So all you're doing is multiplying. You can use the commutative property if you want and change the order in which you multiply things. But again, you're just multiplying. In a problem like this, the way I'm going to approach it is I'm going to multiply these two together first. Hey, a monomial times a binomial distribute, 2x squared, and a minus 6x, and hopefully you agree. Now here's the difference. The product of this box has to be multiplied times this sum of a square, right? So the key here is this has to go in a parentheses because it is that times quantity x plus 2 quantity squared. If you don't put that parentheses there, you're going to get it wrong. Be careful with that. You might say, well, I wouldn't know to put the parentheses there. Yeah, I know. That's why I just showed it to you. Okay? So you need that parentheses. Now, I can use my pattern here in the back. So I'm going to do the pattern in my head. The first term squared, okay, plus sign, 2 from the pattern times the first times the back. So positive 2 times x times 2 is a positive 4x, plus sign, pattern, and the 2 squared is a 4. Now again, you say, I don't remember the pattern. Okay, not a problem. Just do x plus 2 times x plus 2 on the side and distribute, and you'll get x squared plus 4x plus 4. Okay? Let's finish this thing up by doing the multiplication. If you want to finish it on your own, go ahead and pause the video. But we're just distributing, right? So 2x times x squared, 2x squared times x squared is a 2x to the fourth, and then a positive 8x cubed, and then a positive 8x squared. Let me distribute the back term in black. So now we got a negative 6x cubed. Again, I'm going to line up my terms, right? And then we have a negative 24x squared. And then we have a negative 24x. All right. Sum it all up. 2x to the fourth plus 2x cubed minus 16x squared minus 24x. And you know what? That's it. So all there is to it. Not tough, not hard. You're simply distributing. So what's the key to the whole lesson? Distribute. Distribute. We can do that. You can do that. But this is going to set us up for everything else the rest of the way. So you've got to be good at it. And so we'll come into class tomorrow and work a few problems, and that'll be it. All right. Have a great night.